as you probably know, I'm not here right now. I am at Kairos, but I'm also here. You figure it out. At any rate, what we got is this. I'm going to go over the wrap-up that we have. The key is going to be uploaded, so you have that as well. Remember, we have a quiz next time. So you're going to want to have your packet together, ready to roll. Right at the beginning, we'll have a few minutes to review beforehand, but then we're going to get going on it. So, first things first. Let's start talking about just a couple things. What do you need to know for the quiz? For the quiz, few things. One, you want to know about charge. Just charge itself. You want to know two, you're going to want to know how you get charged from friction, how you get charged from induction, how you get charged from conduction. In addition, you need to know polarization. And remember, with polarization, it's neutral. These guys are actually charged, but this guy is neutral. So you're going to want to know about that. You're going to want to know Coulomb's law and how to use it. And that's sort of basically it. I'm just sort of taking a look at the wrap up now, and that's sort of it. So let's work some problems. First thing, it's going to be asking here. So on this guy, for the following 6 questions, identify the objects as either being positive, negative, or neutral. What I'm going to do is I'm going to pause this in just a second. So the sub's going to go and pause it. I want you guys to go and work through these 6, and then we're going to come back in a second and take a look at it. So if the sub could pause it right now, that would be awesome. Well, I see we're back. Isn't that exciting? How did it go? So, formally neutral object just lost some electrons. Guys, you know how we do this. Drawing pictures. Draw the pictures, get the logic. So you get an object, neutral object. It's going to be neutral, so it has positive and negative. Lost some electrons. Boom. Loses the electrons. That means, well, what's left? Positive. So that's why this guy is going to be positive. Next one, it says, object which attracts neutral paper bits and attracts a negatively charged. There's the key. Attracts negative. If it's going to attract negative, that means it's got to be positive. Okay? The next one, an object which repels a balloon, okay, which is repelled by a positively charged balloon, okay? So let's think about this. An object repels a balloon, which is repelled by a positive. So we've got balloon E. This guy is repelled by positive. So what charge does that mean that it is? Very good, I can hear you from here. It means it's got to be positive, okay? So, an object which repels a balloon, which is repelled by a positive, those are positives. What repels it? A positive. So there, that's going to be a positive as well. Object A is charged by contact using a negatively charged object. We draw it. Here's the object. It touches. Charged by a negatively charged object. Well, if it's negatively charged and this guy is neutral, that's going to be conduction. And so therefore the negatives are going to go inside and I'm going to get more negatives, which means it's going to be negative. Okay? So far, so good. Let's keep going. Object A is charged by induction. Okay, let's be careful here. Induction by positively charged. Here's your positive charge. Here is your object. We'll make it an electroscope. This positive, it's going to take the neutral electroscope. The positives are going to attract the negatives. So the negatives are all going to come up to the top. So we're going to get a polarization. So here's all these negatives here. And then we've got these positives which are down there. But remember, this is neutral. We are charging using by induction. Okay? So now what happens is we touch it to ground it. This positive is telling electrons, get out. And so they will, and they'll get out into this. So I'm going to lose these electrons. And so therefore, okay, as we go and, oh, by the way, I'm being an idiot right now. Sorry, it's positively charged. Boy, this is where we could use some editing, but we're not. Anyway, it's saying electrons come here. So the electron's going to try to go up, up, up into it. Now when you touch it, the electrons are also, from this guy, going to go into it, okay? Meaning I'm going to get more and more electrons. And so therefore, it's going to be negatively charged. So let's see if we got that right. Positive is going to attract the electrons. So this guy's going to be polarized. I touch it. Now it actually allows electrons to flow into it. It becomes really negative, and so that's why it's negative. Remember, when you have an object which is being used conduction, it has the same charge as the thing which is trying to go and affect it. So that's why for this one, contact using a negatively charged, because it's contact, okay, and it's conduction, it's going to be negative. This guy, though, is induction. Not touching it, it's inducing it to become polarized, and then the charges are going to be drawn into it when you actually ground it, and so therefore it's going to get the opposite charge to it. Remember, you go through the logic. Object A is used to charge an aluminum plate by the method of induction. The aluminum plate acquires a positive charge. Okay, here's object A. Here's the aluminum plate. Okay, the electrons. Object A is used to charge an aluminum plate. The aluminum plate gets a positive charge. Boom, positive, positive. There's your aluminum plate. Remember, that means this guy must have lost electrons. If he lost electrons, boom. If electrons are going into it, what charge do you think this guy must be? He's got to be negative to draw them and have them move away. And so therefore, that is going to be a negatively charged. Also remembering, with induction, you get the opposite charge. All right. Let's move on. Going to go to this guy. Boom. Read this over, figure it out. And we're now at the sub. If you could turn it off just for a second, and then we'll come back to it. Hey, we're back. Awesome. Two uniformly charged spheres are firmly fastened to and electrically insulated from frictionless pucks on an air table. That means they can move. The charge on sphere 2 is 3 times the charge on sphere 1. Which force diagram correctly shows the magnitude and direction of the electrostatic force? All right, as we take a look, here we go. This guy's cool because they're both being positives and that sort of stuff. But we've got a problem. As we go, we take a look at these. We're going to notice something. These arrows are of different sizes, okay? Also, we got some weird stuff going on. Like this one. This positive is going, no, this is going to be repulsion. So that's not going to work. That's the same problem here. Positive, positive, they're going to repel. So they want to be going opposite. So then you sit there and say, well, what about 2? This guy's going up, so getting a nice repulsion. Well, that's cool. And so is that guy. That's cool. This guy, he doesn't know what the heck he's doing because he should have some force. And this guy's okay. So we got, oh my God, so we got these 3 that are possible. And then we get back to our old friend. A mosquito hits a car on the windshield. Who gets the greater force? The mosquito on the car or the car on the mosquito? And all of you guys should shout out right now, they're both the same. And that's why it's 5. The forces are equal. For every action, equal and opposite reaction. Equal, opposite, reaction, boom. Forces are going to be the same. Okay, let's go to this next one. Negatively charged balloon is brought near a metal can, rests on a wood table. The side of the can opposite the balloon momentarily touched. The can is then. Let's get the sub to turn this off just for a second, and then we will come back to it. All right, we're back. Picture. Negatively charged balloon. Hello, balloon. Is brought near a metal can. Rests on a wood table. That means it's insulated. The side of the can opposite the balloon is multiply. So let's first see what happens. This guy's telling electrons, go away. Electrons go away. So what's going to happen is we're going to get a positive charge here. We're going to get a negative charge there. Okay? So the side of the can opposite the balloon is momentarily touched. So we're going to go and we're going to touch this. So in other words, we're grounding it. This is just like the induction. These negative charges will go away, leaving this guy positively charged. Okay? And so this guy is going to be positively charged. Alrighty, let's keep moving on. Here we have 9. Alright? Once again, sub, please turn this off, and then we'll get back to it. Okay, let's take a look at this guy. An electroscope, okay, is negatively charged. So here's our electroscope. It's negatively charged. So we get a deflection here. That means we get excess negatives. Excess negatives, not nearly as many positives, okay? A rod is slowly brought towards, but not touching the knob of the electroscope, and the leaf falls. Well, if in fact it falls, that means that in this case, it is going to be drawing the electrons up away from the leaf, okay? So these electrons are going to get drawn up. What is it that's going to attract the electrons? Positive charge. And so therefore it's C, positively charged. Okay? Let's head on to the next one. Whoop. What I want you guys to do now on this guy, I want you to go and do 10 and 11. Do 10 and 11, okay? Do it. Sub, if you could turn it off, and we'll take a pause. All right, we're back. Negatively charged balloon will be attracted to a neutral wooden cabinet due to polarization, which best describes why this occurs, okay? Well, let's do a picture of it to begin with. Here's our negative, and here's our cabinet. That means the cabinet itself will have the positives attracted and the negatives repelled. Everybody cool with that? So that's why when we look at this, we take a look, we say, well, which one's like this? It's D. Remember, if you go and work it out first, then look for the answer, it's a lot easier, okay? So do it first, then look for the answer. Remember, this is not possible, that's not possible, because they have only one charge, and they need to have both charges, because it's a neutral object, and that's why this guy's no good, okay? This guy's no good because positive and negatives are sort of mixed, and this one you got negative next to a negative. Let's move to 11. Negatively charged balloon is held above without touching a neutral electroscope. The presence of the nearby balloon causes the needle of the electroscope to deflect. Now remember, this is not touching, that's negative. So what's going to happen? It's going to tell electrons, get away. So the electrons are going to move down here. 1, 2, 3, 4, 5, 6. 3, 4, 5, 7. 7. Okay, got 7. So I'm going to put a couple positives here, and then 5 more up here. Because remember, it is neutral. So you got to have the same number of positives and negatives. Okay? So draw the location of types of excess charge on the polarized neutral electroscope. Remember, always neutral if it's polarized. Explain how the balloon has induced the temporary charge upon the electroscope. This is where we're talking about the attraction of the electrons going upwards towards that positive charge, and also taking the electrons and moving those away. Okay? We're cruising now. Let me take care of this stuff here. Whoopsie. All right. 12 and 13. These are like ones we've done before. Right now, guys, go through, work 12 and 13. We're going to take a little break, and then the sub can turn it back on. So sub, please turn it off. Hello. We're back. Remember, these are our traditional ones that we've got, okay? It says, at a separation, okay, of 0.5 meters, 2 like-charged balloons experience a repulsive force of 0.320 newtons. This is one of those things. If it's doubled, what's going to happen? Okay? Well, we know that the equation we're working with, Coulomb's law, force equals K, Q1, Q2, over the distance or the radius squared. Okay? That's our equation. We also know that this guy is 0.320 newtons. Just like we did before, what we're going to do is we're just going to simply go in And we're going to go and say, okay, this is K, Q1, Q2, and leave the space so you can put the thing in. It says the distance is doubled. That's going to be 2, but it's 2 squared. 2 squared is 1/4. So we're going to go 0.320 newtons. And then we're going to go times the 1/4. And we're going to be getting 0.08 newtons. Okay? This is just like we did before, remember, when we were doing the gravitational problems. Alrighty, same thing. Separation distance, all that sort of stuff. Repulsive force is 0.320 newtons. And we have our K, Q1, Q2, R squared. Remember, keep that space. If the distance is increased by a factor of 3, and the charge of both of the balloons is doubled, boom, we get that. So therefore, we should get 0.320 newtons, and 2 times 2 is 4, 3 squared, 9. So you're going to work that through, and it's going to be 0.142 newtons. Everybody cool? You've got to expect this is showing up, folks. Remember, this review is very indicative of what's going to be on the quiz. All right, heading into the home stretch. Now we're going to actually do some problems with that. So let me go and take a look here. So, sub, we're going to be doing 14 here, okay? So, if you could go and stop the tape real quick, and then we'll come back in just a second. And we're back. All right. We go, charge of QA, experience an attractive force. Force, 1.5, 10 to the second newtons. Charge of B, okay, located with the R being 0.024 meters. Remember, you've got to be in meters. Okay, QB has a charge of 5.2, 10 to the negative 6 coulombs. That's a microcoulomb. What is the charge of QA? And we know what K is. So you go, the force equals K, QA, QB, could be 1, 2, AB, whatever you want, over R squared. We want to figure out the charge of QA. So let's isolate for it. Bring R up. Force times R squared divided by the K times the QB. Now we just put our numbers in. So the numbers that we're going to be having is 1.5, 10 to the second newtons. The radius, which is 0.024 meters squared, divided by 9 times 10 to the 9 newtons, meter squared, coulomb squared, that's your constant, always the same, times the charge, 5.2, 10 to the negative 6 coulombs. Okay? When you go and you work that all out, you should find out that it is 1.8, 10 to the negative 6 coulombs. Now, the question then is, I have a positive, okay, charge which happens to be here. We have it's a attractive force, okay? Attractive because it's a positive there, so that means if this guy's positive, this guy must be a negative. Okay? All right. Now we're going to get into 15. So, sub, once again, if you could stop it. And now we're starting again, and I'm just sort of erasing this stuff as I go. All right. Let's take a look at this sucker. As I said, we're so close we can feel it. 2 objects are located along the x-axis. Object A, charge. Okay, so we got, I'm just going to give the data here. QA, positive, 0.25. It's a microcoulomb. Remember, don't get freaked out by that. That's going to mean that it's equal to 0.25, 10 to the negative 6 coulombs. Located at the origin. Then we got B, I'm just putting the data out now, negative 16 microcoulombs, which is 16 times 10 to the negative 6 coulombs. And the distance is 0.62 meters. Okay, we are going to sketch the scenario. So here is A, QA, okay? And here's QB. We realize that the distance that's between them, okay, is 0.62 meters. And we know the charges of each, okay? And so it turns out that this is, this one's positive 0.25, 10 to the negative 6 coulombs, and this is negative 16 times 10 to the negative 6 coulombs. If that's positive and that's negative, then that means we're talking about an attractive force that exists between them. Cool. So, what's the magnitude and direction of the electric force of A on B? No problem. So now we sit there and say, okay, we go that the force equals K, QA, QB over R squared. Well, this is sort of easy. We don't have to rearrange the equation. So we just go 9 times 10 to the 9th newtons, meter squared, coulomb squared. Yes, you will be given that on the quiz. And then you're going to put in the first one, 0.25, 10 to the negative 6 coulombs, 16, 10 to the negative 6 coulombs. Now, I'm not going to worry about the charge too much. I'm going to worry about it being attractive from that. So I'm just going to use the absolute value there for that guy. And then we get 0.62 meters squared. When you work this out, should be 9.4 newtons. Now, we want to know the force of A on to B. So when you think about it, you say, hey, I am A. That's B. This is an attractive force. That means I'm going to be heading towards B, which is right. Or east. Okay? Right or east. Everybody cool? All right. Now, if the sub could go, and we're going to be turning this off in just a second, you guys are going to be doing, oh, I'm sorry, I take it back. My bad. What's the magnitude and direction of force B on A? Well, if we know, here's A, there's B, we know the force of A to B is 9.4 newtons to the east. That means this has to be an equal force. So the force of B on A is going to be 9.4 newtons, but now we've got to think B on A. That means that particular one is going to be going in the opposite direction to that guy. So we're going to sit there and go, oh, magnitude, direction, electric force of B on A? Boom, it's going to be to the left. Or west. All right. Last guy here. Okay, and this is the last guy in here. So, folks, sit there, take a look at this, and then I will come back in a second. So, Seb, if you could turn it off just for a second, go for it. All right, once again, we've got a situation with the picture, but the picture's done for us. A rod, positive charge, placed near an uncharged metal sphere. There's the conductor. So we automatically already know this positive is going to attract those negatives. Negative's going to move up. Positives sort of are going to be left behind. Okay? So what's happening in figure 1? You're getting a separation of charge. Negatives going towards the positive. What do we call that? Polarization. Okay? Now, next one. If the bottom of the sphere is grounded, as in figure 2. Okay? So here it's grounded. Remember, what the grounded means is it's now connected. And so charge can move through it. This guy's saying, bring the electrons to me. Now it can't go across there, but it's going to bring it, so it's going to bring electrons up. So these electrons are going to go through the ground. So if the bottom of the sphere is grounded, as in figure 2, electrons are attracted to the positive charge. What does it do to the overall charge of the sphere? Well, if I'm putting more negatives in there, guess what? It becomes negative. If the connection to the ground is broken, okay, so here these charges are going in. I'm going to break this guy. Now what's the sphere going to look like? Well, we know this is going to be negatively charged. It's going to have excess negatives in. And what they did is, this picture is not the best. This is equal, this is positive, so it's going to be C, so it's going to be the negative which is there. So it's going to have a net negative charge. Okay? And then, question is, what happens if the charged rod is first removed and the ground is then broken? Well, if I remove the charge, so let's say we have these negatives that have moved up into here, okay? They've moved up into there because they're attracted to this. So if I go and remove this guy, there is no longer the force to do so. So the electrons are going to go back to their original place. It's going to become neutral again. And so that's why. It's then broken. What's it going to look like? It's going to look like A. Okay? Because the excess charge has been gone. Last one. What would happen if the rod were negatively charged and the ground was broken before the rod was removed? Okay? Well, let's draw. So now we've got a negative charge. Negative. Here's our sphere. This guy's saying, electrons go away. Electrons away. All right. So that means, and this is grounded, it says. So now what's going to happen if the electrons want to go away? And they'll go through the ground. And it'll leave it being positive. Okay? So what would happen if the rod was negatively charged and the ground was broken before the charge was removed, and now you break it, so these guys, so the electrons can't go back in, sucker's going to be positive. Okay? Folks, this is the stuff that you've got. So what we're looking at is, know how to do the things that are on here. No big surprises on the quiz. When we come back, we will have a little bit of time to go over some stuff. I'm going to be doing a review Thursday morning. And then you're going to take the quiz on Friday, so you can come by there. It should be okay. So, thank you much. See you in a couple days.